Good morning. Welcome on the first lab for the course Neural Networks. At the beginning, you already noticed when you connect to the Zoom room that this lab will be recorded. And for the record, I must say that in the record there will be no recorded your names, and if you don't turn on your camera, you will not be seen on the recording. On the other hand, I would like to interact with you, so I need at least some reactions from you. So before anything from the course, I would like to ask you to raise your hand. In the menu below, you can raise your hand, and yes, I see that you know it already. Excellent, but not all have raised their hands. Please try it. And similarly, when you have any question, then you can just connect your audio and ask, and I can answer it directly, or you can use the chat window to write the question. The chat is by default not included into the recording, so you don't be afraid that you will be identified from the chat that you have given this one question or note. Okay, so thank you very much for the reactions. Not all of you raised your hands, but please lower your hands by clicking the icon again. Yes, I can see that you managed to do that. And now some information about the course. So you have noticed that the course has two labs and 2 lectures. The labs are meant that only one of the labs you should choose, and according to the student information system, most of you enroll the lab on Wednesday, not on Thursday. So I will try to convince the colleagues from Thursday to join us on Wednesday and to have the lab only once per week. But if I will not succeed, then I will keep these 2 labs synchronized approximately. This means that if you cannot take part in one of them, you can take part in the second one. I have sent you an information about the course. You can find some information into the student information system, but more important is that for the course there exists a Moodle course at the address dl1.cuni.cz. This is in the email I have sent, and I ask you to enroll into the Moodle course, because there you will find relevant information, at least slides, and also some materials which will be used during the labs. So let me switch to the Moodle course, and I will continue with that. I must find the proper window. Okay, and now I will share the correct window, I hope. This one. So now you should see my web page in Chrome with the server dl1.cuni.cz. There you can find all the courses, and if you look at the list of the courses, there is Matematicko-fyzikální fakulta, and under that there is KSVI. This is the department I'm working in, and there is the course neural networks. Here, neural networks. Of course, to see the contents, you must enroll and first log in to the server. So I will log in, and now I can enter the course on neural networks. I will switch to English interface. So here you can find slides. The slides are some of them are in Czech. For example, here vrstevnaté neuronové sítě. So you can find slides in Czech, but the most important are the English slides, because the course will be taught in English, and subsequently the English slides will be extended by videos with audio comments from my wife Iveta Mrázová, who will actually give the lecture. I am responsible for the labs. You probably have seen the record of the subject neural networks in student information system. And then there you can find conditions for obtaining credits for the course. So I would like to go through some of them here. So within the lab, as you have seen, the Moodle course is the most important source for information. And during the semester, there will be 4 assignments. Assignment will be published in the Moodle, and there will be at least 2 weeks to submit solution of the assignment. Each assignment will have a deadline, and until which it should be submitted. Actually, you can submit your solution also after the deadline, but with a penalization. And the penalization is quite small, so the maximum grade you can obtain for solution of an assignment is 10 points, and for each started week of delay, the penalty is 1 point. I understand that teaching online only can be hard not only for a lecturer, of course, also for you as students. You have many subjects and so on. You could have some problems, for example, health problems. If you have any such bad conditions or problems, please contact me, preferably by email, and I can arrange something that, for example, postponing the deadline or something, or help you with the assignment. So the most important thing is that I must know that you have problems, then we can discuss it, and we can find something which can help you to solve the situation without, for example, the penalization, because the points are accounted to the final grade of the exam. For the assignments, you should submit description of the solution. This could be some separate text file, preferably in PDF or RTF format, and then source codes for solving the assignment. Usually, it will be required to pack it into some zip archive and submit just 1 file. Small warning, but I hope this is not so necessary. If I find that several solutions are very similar or identical, I will take that solution like one solution. I will grade it, and then I will divide the points among all the students who submitted the solution. The solutions will be stored within the Moodle, so I can check it also later. So if I miss the solutions were similar and I will find it later, I will decrease the grading. On the other hand, if you are working on the solution, you can discuss your solution with your colleague or with me. It's completely okay, but you should write scripts and description of the solution by your own. Then there will be also online quizzes. Online quiz is a set of some questions. You enter answers to the questions, and then you obtain almost immediately the evaluation. The evaluation will contain just the obtained points, not detailed description which question was answered wrong or what was the wrong answer. Only after the deadline for the quiz, the correct answers will be accessible to you. In contrast to assignments, the quizzes cannot be solved after the deadline. So be aware of that. There will be one special assignment called entrance test. It's already opened. I will show it in the Zoom in a while. And for that, you will obtain 10 points. But subsequently, there will be more smaller quizzes, which contribute, I think, around 5 points each. For obtaining credits from the lab, it's necessary to solve all the assignments and to obtain at least 1 point for each solution and present a term project. Term project is very important. In the term project, you should apply some knowledge from the lecture or from the labs to some real-world problem. So the intention of the term project is that you obtain some real data and apply some model of neural networks to solving some question from the data. For example, for classification of the data, you build some model of neural network, and you report that if I have such a network, I obtain such accuracy. If I increase the size of the network, the accuracy changes in this way, and so on. For the TEN project, I will in a while I will show you, and you can find presentations from previous years. So there are many presentations you can get inspiration for your project. The subject for the project will be discussed in the middle of the semester. So for obtaining credits, it's necessary to solve all assignments and prepare and present your project. The presentation will take place in the last week of semester, and in the last week of semester we will set up a date, one more date in the exam period, where the rest of the presentation can take place. If you will take part into the labs, you can obtain additional points. If you demonstrate a solution for a problem which will be assigned during the lab, then it's usually awarded by 1 point. And after the deadline for an assignment, we will discuss the solution in the lab, and you can obtain, if you present your solution, you will obtain one half of the grading of your solution. So during the semester, you can collect points from assignments, quizzes, term project, and additional points from presenting your solutions during the labs. So altogether, you can obtain 85 points during the semester in the labs. Of course, if you are active and demonstrate more solutions, you can obtain even more than 85 points, but only 85 points will be accounted, and this will be accounted for 35% of the evaluation of the final exam. The lecture, as I said, will not be held online, at least for the beginning of the semester. There will be only commented slides, but there usually, when there were ordinary teaching, there were some tests during semester which accounted to some part of the grade. This will be replaced by written assignments. So be prepared for that. And below you can see table for the grading. So have you any question regarding the conditions for obtaining the credits?
Can I ask?
Yes.
Can I use Python for assignments or only MATLAB?
I will come to that. In general, not. In the labs, we will use MATLAB.
And if I have some projects, for example, different neural networks in Python, can I use them for
the project?
Yeah.
Excuse me. For the project, the project should demonstrate that you apply some model of neural networks. So you need not to program the model. If you have accessible any implementation of a neural network, the subject of the project apply a model on real data. So if you have something programmed in Python, then you can use it for the project. It's no problem.
Oh, okay. Thank you.
Is this what was interesting for you?
Mm-hmm.
Yes. Okay. Any more questions? If not, I will go back to the Moodle course. So in the Moodle course, you will find the slides and also useful links. If you look there, you can find there some online books on neural networks. For example, Roya's textbook, Neural Networks: A Systematic Introduction, covers some substantial part of the lecture. And there are more. Already mentioned, we will use for the lab, we will use MATLAB. So there are some sources for the MATLAB. And here are older projects. So if you look some very old or some more recent projects since 2011, if you open that, you can see a long list of presentations, and you can look in some of them, and you will see what was presented in as the TERN project. Okay, then there are two discussion forums. One is news. News is from teachers to you, to students. So here only teachers can post announcement, and I will post there as the first announcement the links to the Zoom meetings. So if you lose the email, you will find it here in the news. So important messages from the lecturer, my wife or me, will be posted in the news. And if you haven't changed any settings, And all messages which will be posted here should be sent also to your default email. Another discussion forum is discussion. We will use discussion forum for communications between you and me and between students. So if you have any question, you can post it there and maybe your colleague can answer it, or I can answer it, or my wife. And so to the discussion forum, you can also post messages. And during the labs, we will use it for submitting some solutions or scripts for the problems we will solve during labs. Okay. Then here is the entrance quiz. If you look here, the deadline is 16th of October, so more than 2 weeks. And you have 2 attempts, and better results will be accounted. You can try the test quiz, and it's not unlimited time. So if you open the quiz, you will have unlimited time to finish it, and only when you are satisfied with your answers, you can submit the answers, and you will obtain the evaluation. In case of any problems, for example, you find some error in the quiz, this is still possible, please let me know, and I will give you more attempts to have the chance to answer and obtain the full credits. So important is communication. As I said, in the lab, we will use MATLAB. Actually, the first 2 labs will be devoted to introduction to MATLAB. At first, I would like to ask you, please raise your hand if you already know something from MATLAB. Have you tried it, or have you written some short function in MATLAB? So I can see quite a few raised hands. Okay. So for sure, not all of you know MATLAB. So the first two labs will be devoted to the MATLAB. You can lower your hands, please. I will start with that in a while. But for the people who already know MATLAB, this can be boring. You can switch off, but before that, I would like to show you the first assignment. It's not visible for you if you cannot open it. It will be a little adjusted. I know that it needs some facelifting. In the first assignment, you will program some functions related with computing with grading the course. So, for example, the first function you will implement is grade. If you submit scores for several students and boundaries for the grades, you have seen the table. I will not go into the detail now. Only I would like to say you that it will be this assignment. The assignment will be published till the next week, and there will be the deadline will be, I think it's already set. For Tuesday, 20th of October. So be aware of that there will be assignment. So for people who already know MATLAB, if you leave now, it's completely okay. You will not lose anything. Or if you would like just to refresh your knowledge about MATLAB, then you can hear the rest. For the MATLAB, it's necessary that you have access to MATLAB. You can install MATLAB on your personal computer. Here is the link for information about MATLAB license for the whole Charles University. If I click it, the information is in Czech. For the foreign participants, if you use just Google Translate or something like that, automatic translation, you will still understand what's written there, and you can install the full MATLAB with long list of libraries or toolboxes and use it. Beside that, you can use also MATLAB Online, which will be enough for most of tasks we will solve during the labs. So if you don't want to make your local installation, you can use MATLAB Online. I will not show it now. You need an account by MathWorks. MathWorks is the company selling the MATLAB. And if you have such an account, you can start MATLAB Online and use it online. So I will switch to my installation of MATLAB, and there are many files open in my window, so I will close them. So if you have already your own installation, please open it, because what I will show can be used interactively, and you can try to modify the statement I will show, and I will ask also questions what is the behavior of some commands when you change the parameters. So in the Moodle course, back. In the Moodle course, there are the topic Introduction to MATLAB is the first topic, and there is PDF file with the description what I will show today, and source code for MATLAB. So you can follow it in the PDF. I have a little cluttered. So you can read it here, but better way is to use the script and try the code interactively. So the script is here, source code for MATLAB. If you open it, it's just a text file. So you can save it in some place where you can access it. For the saving, please don't use the extension txt and put there extension m. Extension m means MATLAB file. So .m the suitable extension. And save it in a place where you can access it. So I download it in my download directory. Okay, I rewrite it, and if you start the MATLAB, oh, okay, I will leave it. So you have integrated environment. Can you read the text? If not, I can try to increase the size of the font. Anybody willing to increase the size of the font? Please use yes in the the reactions. Yes, at least one. Okay, so this can be done in preferences. References, editor, no, editor, fonts, yes, this here. So fonts and command history. Oh, maybe it's better to increase the size. The editor still. Oh, no. Desktop. Editor. So in the integrated environment, there are several windows, and on the left, I have the window with current directory. You can change it here by entering, or if you can list any directory. So I will switch to downloads, and in downloads, the file, I have too many files there.
I think you aren't sharing the MATLAB window, only the Chrome.
Oh, thank you very much. Thank you very much. I hope now you see the MATLAB window. So I was changing in preferences. In preferences, I was changing font here, font for command history and editor, and for some other parts. Okay. So on the left, this is the directory, and I must find the downloaded file there. It's this one, UWOD UTF-8 _en.m. By double-clicking the file, an editor window will appear here. I will make it a little wider. And this is the script. The script is specially formatted. Each line which starts with $sign is a comment in MATLAB. So all these lines are comments, and it's the comments are formatted in such a way that we can produce HTML file of that, or PDF. And the PDF I was showing to you was actually generated from this script. So this is a gentle introduction into MATLAB. MATLAB is an old program developed for more than 40 years. And it was developed as a program for working with matrices. So the name MATLAB is abbreviation of Matrix Laboratory. It was designed for easy working with matrices of real numbers, but nowadays the data structures are richer, and some of them we will mention the next lab. Basic usage for MATLAB is for solving linear equations, computing eigenvalues, eigenvectors, factorization of matrices, It has very rich graphical capabilities, so many types of graphs can be produced from MATLAB. It has its own proprietary programming language, and we are looking at source code for script in this language. And it's designed to solve problems numerically, not symbolic way, but actually it's now possible. There is a library, so-called toolbox, for symbolic computations too. Nowadays, MATLAB is de facto standard for technical computing, and this is one of the reasons we will use MATLAB. Its syntax is very simple, so you will understand it in a few minutes, and then you can use it to your advantage. So what we will use usually will comprise some short script, several lines of code, and everything will work as expected. So it's now used for simulations, controlling devices, for computer vision, machine learning, deep learning, and so on. So endless. There are some free clones of MATLAB. The best one is GNU Octave. If you see these vertical lines along the GNU Octave, it's for formatting. Don't bother with that for now. And GNU Octave has also some integrated development environment, but MATLAB it's a little more mature. There are many such clones. For example, FreeMat is another one. In MATLAB, we can compute. It's for computing. And the default data structure is a matrix of real values. So we can easily enter vectors and metrics. I haven't mentioned that. You can see that if I have cursor in some place in the script, or some portion of the script called section is highlighted, and this section can be run section here. All lines in this section start with %, so this is only comment, and if I run it, nothing happens. But if we come to the section which titled Simple Mathematics, there is some code here. The code is the last line of the section, and if I run the section, I obtain results here down. So the command here was assigning row vector with numbers 2, 3, and 4 to the variable x. You can notice that between 2 and 3 there is a comma, between 3 and 4 there is just white space. This can be space or several spaces, tab character. Both always possible, commas, spaces, tabs. And the result is a row vector. If we would like to have a column vector, then we should separate the elements using semicolon. So if I execute the section, and I will use this button run and advance, so the focus will be moved to the next section. So the result is Y is a column vector. In order to see more in this command window, I will issue a command format compact. This will remove white empty lines which are around the outputted lines in the command window. So if we have Y is now column vector, X is a row vector. If we multiply them from algebra, we know that the result will be a matrix. So the result is now matrix with dimension 2 times 3. If we would like to enter directly a matrix, we can do that on single line. Here we will enter matrix A, and these are the elements of the first row, and the separator of rows is the semicolon. So after semicolon, we continue with the second row, and the bracket is the end of the matrix. So if I execute that, I obtain matrix A. Notice, please, the display, how it is displayed here. There are also almost all elements are 0, and only one is 1.3. Why is that? Because in our matrix here, this element is very big, 1.3 times 10 to the 12th power. And the 10 to the 12th power is common multiplicative factor, which is displayed as the first line. And then all these numbers should be multiplied with this factor. But all the remaining values are very small in comparison to this element on the second row and second column. So it's displayed like 0 elements. But these are not 0. The real actual real values are stored in the matrix, of course. We can enter also matrix directly by separating the rows of the matrix by entering a new line character. So using the enter button on your keyboard. So if I execute this one, I obtain matrix B. Scalars are simply matrices of size 1 times 1. And we can enter them without the brackets, just the value. And from linear algebra, you know that we can multiply matrix Z by a scalar A, and the result should be matrix where all elements of Z are multiplied by the scalar A. And if we run the command, this is the really the output. I will execute down, enter Z. You can see this was the matrix, this original matrix Z, and scalar was 3.1, and so this was the result U multiplying A times Z.
Excuse me, can I ask?
Yes.
Please, what separates two sections? For example, one section of code from another.
The separation sections is any line which starts with 2 person signs.
Okay, thank you very much.
So MATLAB distinguishes case of the letters in names of the variables. So be aware of that. After working for some time in MATLAB, you will end with a long list of variables. Using the function who, you can list all the defined variables, because the variables are not declared, just defined. So when you enter a value to a variable, the variable will be created for you. Other possibility is look here to the right on the workspace window. There is also a list of your variables. This can be also helpful. For example, if I look at capital A, then you can see that it's actually a matrix. And it's not so big, so you can see the whole matrix here. But if you double click, excuse me, wrong. If you double click the variable here, a spreadsheet will open. And in the spreadsheet, you can check the values, and you can also change the values there. For example, 2.3, I will change it to 4.5. And if I print out the matrix A here, this will be not visible, but this was the first row, first column. And it's now 4.5. Okay, I will close the spreadsheet. More usable function for displaying defined variables is whos. Whos will return a list of variables together with dimensions, size in bytes, and type of the elements. So capital A is matrix 2 times 3. The elements are doubles, real values, and it occupies 48 bytes of memory. Okay, so let us continue with arithmetics. MATLAB tries to compute in a robust way. So if you divide by 0, A divided by 0, A was 3.1, divide by 0, the result is infinity. So it's special. I click it twice, excuse me. So here the result is infinity and the value inf. And MATLAB can compute with such infinity. For example, 1 divided by infinity is really 0. But if you divide infinity by infinity, you know from algebra or from mathematical analysis that the value of such expression is undefined. And when we execute that, we obtain NaN. It's abbreviation for not a number. So undefined value. MATLAB can compute square roots of negative numbers. So here I compute square root of -1, and the result is complex number. Complex number with 0 real part and imaginary part 1. The imaginary part is denoted by this letter I, and it could be, instead of I, we can use J. And this is in the next section. Here in this expression, I take one complex number, 1 plus 2i, and multiply it by the second one, 1 minus 2j. J is also the imaginary unit, and the result is a real value 5. If you imagine some simple arithmetic operations, all the operations are available in MATLAB. So power 2 to the third power, to the fourth power, to the 100th power, combination in some expressions, it's nothing surprising for you. What you may notice here, the answer from MATLAB is sometimes ans equal sign and then a value. If you execute an expression and the value of the expression is not assigned to a variable, then the expression is evaluated. The value is displayed and assigned to a special variable ans. If you look to the right, here in the window of workspace window, you can find also the variable ans. This is just ordinary variable, so you can compute square root of the ans variable. Goniometric function, sine, cosine, constant p is there. You can use it freely in your expressions. But actually, if you assign some different value to p, pi variable, then when you use it later, you will use your constant pi, not the correct value. Logarithm, you can compute logarithm. So logarithm of 2430 is 7.79 and something. What is the base for the logarithm? Can you say me? So of course, if you look at the result, 7 something, so it's not the base 10. So it could be base 2 or natural logarithm. How can we find out? We need help. Help and name of the function, help log, will display help for the function log, and you can see here that this is the natural logarithm. And see also here you can see log2 will be logarithm with base 2, log10 will be logarithm with base 10, and inverse function, exponential function is exp. For the help, you can look for other places. For example, here is a special button with the question mark. I'm afraid you cannot see the window what it popped here. I will not go in there. You can enter the name of the function in this small window, and then you can obtain the help from MATLAB. I'm afraid that you still don't see. Maybe I will change to sharing just the whole screen. So now you see the window. Why I'm taking so much time of that? This help is the most comprehensive. So it has examples when there are plots, there are pictures for the plots. You can open LiveScript. This is the online version of MATLAB, and try the function. So this is the most suitable documentation for MATLAB, for functions in MATLAB, and most suitable tool for experimenting or finding information, detailed information about function. I will go back. Here is a special function, a special button, fx. It's help for functions. So if you open it, and we can also enter the name of function log, and if you click it, you will obtain some brief information about the function, natural logarithm. But the information is not so detailed as in the hypertext help I have already shown to you. Okay. For example, this means that in the generated HTML file or PDF file, there will be included some picture, JPEG picture. Okay, let us continue with matrix operations. So all standard matrix operations are supported in MATLAB. So we will prepare some matrices. A will be matrix of dimensions 3 by 3. B is also square matrix 3 by 3, and C is 2 by 3 matrix. So if I execute that note please that these lines are ended by semicolon. Ending a line by semicolon or command by semicolon means you don't want to display the result of the command. So the matrix A is not displayed, matrix B is not displayed, matrix C is not displayed, but the result of the command whos is displayed. And this is here, and here we can check the sizes of the matrices. So A plus B is just summing two matrices of the same shape. A minus B, it's similar. This is commented because if I execute A plus C, and I will do that in the command window below, A plus C, the result is an error because A and C matrices have different dimensions. So it's not possible to sum them. Matrix multiplication works as expected and computes matrix multiplication. Sometimes, however, so A times B is matrix multiplication. But sometimes we need to multiply two matrices not as matrices, but only multiply the corresponding elements of the matrices. So if I display here matrix A, and here I display matrix B, so these are these two matrices. I would like to multiply 3 by 1, or this 3 by this 3, 5. So only the corresponding elements. It's possible by issuing a command a dot star b. So preceding dot preceding the operation will apply the operation element-wise. Multiplication by scalar I can skip. So this is and the result is element-wise multiplication. Matrix transpose. So if I have matrix A of dimensions 2 times 3, transpose is A apostrophe. This is a transpose, but actually this is not transpose. This is a complex conjugate transpose. Let us prepare some complex matrix. So it's done here. So assign to matrix B, I assign matrix A. It contains only real values. And add 1 times I, so this is the imaginary unit, I, times random matrix of dimensions 2 times 3. The function rand generates random values from interval, from uniform distribution on interval 0, 1. So this will generate some matrix with value between 0 and 1 and of the shape 2 rows and 3 columns. And I subtract 1/2, so some of them will be negative. So if we execute that, we can see that, for example, the element in the second column of the first row has negative imaginary part. And if I use this apostrophe operation, I obtain the complex conjugate. Complex conjugate is transposition, but the sign of the imaginary part is flipped in all elements. If I would like to have just the transposition, I must precede the apostrophe with the dot period. So now this is just the transposition without changing the signs of the imaginary part. We will experiment with some data and some artificial data, and for that we need to generate some matrices. There are many functions for generating matrices. Zeros generate matrix with zeros elements. So the dimensions are here 2 and 3. So the result is matrix of dimensions 2 times 3 with all elements 0. Similar function is ones. 2, 3 will generate matrix with 2 rows and 3 columns, and all elements are 1. Please try to call the function zeros, but with just single argument. Example 0, 3. What will be the output? Anybody knows the answer? Please raise your hand who knows the answer. I will switch the sharing to just the MATLAB window. Only 3 hands, only 3 of you know the answer. So, Kolik Magyara, what will be the result? Kolik Magyara, can you say me what will be the result? Zeros and just single parameter 3.
3 times 3 matrix of zeros.
Yes, so square matrix. And what will be the result if I put more than 2 parameters? Zeros, 2, 3, 4. I can do that. and I obtain something like this. What's the result? The result is three-dimensional matrix. So in MATLAB, we can use matrices of any dimension. So this is three-dimensional matrix displayed according to the last dimension. So when the last dimension is 1, it's this matrix. When the last dimension is 2, is this matrix, and so on. I is a function which generates identity matrix. So it has only one parameter because the generated matrix is a square matrix. On diagonals there are ones and zeros elsewhere. Diag is a function which puts the vector, which is a parameter of the function, on the diagonal, and the rest of the matrix will stay 0. So 1, 2, 3 is on the diagonal, and everything else is 0. Now let us look how to solve a set of linear equations in MATLAB. So if I have a linear equation, I will type it here. So if I have equation 5 times x should equal y, how to solve such equation? I would like to know y should equal 7. How can I solve such equation? I simply divide the left hand side by 5, and simultaneously the right hand side by 5, and the result will be 7 divided by 5. This is the solution. Similarly, we can do that in MATLAB, even in case we have matrix equation. So if capital A is a matrix, X is a unknown vector, and B is a column vector known values. We can solve it by, we should get rid of the matrix A on the left side. How? We should multiply both sides from the left by inverse of matrix A. You know that not all matrices, for all matrices, there exists an inverse matrix. And MATLAB, you can use operation which you should not show to anybody from the algebra department. So be aware of that, because the people would get angry. In MATLAB, you can divide by matrix. So let us prepare such a system of linear equations. So I will generate a random matrix 3 by 3 here. I will generate the column vector B. So it will have 3 rows and 1 column. So this is my matrix A and my vector B. And I would like to solve the equation A times X equals B. So I will divide both sides from the left by the matrix A. So it's done here. So the matrix A on the left-hand side will be eliminated, and on the right-hand side there should be B divided from the left by the matrix A. And if I execute that, I obtain a vector X. And we can check whether the vector is the real solution. We just compute A times X and subtract B out of that, and we should obtain 0 vector. What we obtain is not 0 vector, but you can see that the common multiplier here is 10 to the minus 16th, so it's almost 0. So it's really solution of the system of linear equations. How to generate some vectors in MATLAB? Here is a syntax. 1:6 will generate row vector with integers between 1 and 6. So this is the result. We can use 2 semicolons and generate arithmetic sequence from value from the first value, from -1 till +1 with step 0.2. So we obtain a long vector, -1, -0.8, -0.6, and so on till 1. Even negative steps are possible. So if I start from 20 with step -3, and the lower bound is 1, lower bound is 1. But if I subtract repeatedly 3 from 20, I never obtain 1. What will be the last element in this sequence? So last element is 2, because the next element would be 2 minus 3 is -1, and this is lower than the lower limit of the sequence. There's a similar function, linspace. Linspace generate equidistant division of a given interval. So 0 and 1 are the limits, and 11 is the number of points in the interval, including the borders. So linspace, with 11 points, will divide the interval 0, 1 into 10 equal pieces, and the results are values 0, 1/10, 2/10, and so on till 1. A similar function, logspace, generates a logarithmic scale. So logspace 167 will generate a logarithmic space, but the meaning is a little different. These arguments 1 and 6 are not the limits, these are the exponents. So this is actually sequence between 10 to 1, so between 10 until 10 to 6, so 1 million, and with 7 points. So this is the answer. So this is not 0, it's actually 10, and these values are in the same distance but on a logarithmic scale. Almost all functions in MATLAB are so-called vectorized. So if we apply the function on a matrix, it will be applied on each element of the matrix. Let us look at some example. So we will prepare a vector t, values between 0 and pi with steps 1/10, and we compute table of values for function sine of 2t. So sine with argument 2 times t, we obtain table of values of the function, and we can easily plot the function. Yes, for plotting this will be displayed in different windows, so I must switch the sharing to screen. So if I execute plot t-tab, t will be used for x coordinates and tab will be used for y coordinates. And there should appear a window with the plot of the function sine of 2t on interval 0, pi. We will see much more plots in a while. Now I would like to point you to this window. Better not so big. I will scale it a little. It's important when you will solve your assignment, sometimes you will be asked to include some plots in your documentation. You can easily save such plot here, save as, and you can select from many formats, graphical formats. So you should select format which will be suitable for your editor you will use for preparing the documentation for the solution. Further, you can change parameters of the plot. So there are here many tools for for example, rotate in 3D. And if we have some function in 3D, we can rotate the plot and find some nice view of the plot. You can change. You can insert labels for axis. You can change colors in the figure. So this window is maybe very valuable for you. So I will close it for now. Next, in the next section, I would like to plot the function 1 divided by 1 plus x squared. This is the function. So I prepare the values for the x coordinate between -2 and +2 at step 1/10. The statement ends by semicolon. This will be not displayed. Similarly, the values for y, and here, note please, here is dot. Why is here dot? Can I omit this dot? Anybody knows the answer? Please raise your hand. Nobody? So x, here x is a vector. If I compute x, x to the second power, x squared is not possible. Let me look what I have in x. X is this is a column vector. Okay, I will make out of this row vector. So x is row vector and x squared. It's not possible because we are looking at the multiply 2 row vectors and use the matrix multiplication. So it's not possible. But what we are looking not to compute matrix or multiply the vectors. We actually would like to compute square of the element of the vector x. So we must compute it element-wise. That's why there is this dot. We obtain a vector. We add scalar value 1 to the vector. But then we would like 1 divided by vector. This is not what we need. We need to compute 1 divided by each element of the vector. So also element-wise. So this is the second dot. And if we execute that, we obtain a plot of the function. Maybe you are not satisfied with the plot. For example, you don't like the blue color. And then you can execute the plot and add a third parameter, third argument. It's a string in apostrophs, and R means you would like to have it in red. If I execute that, it's displayed in a window, but the window is hidden. I must take it to the front. So now it is in red. Maybe you don't like red. The next plot is in green, and the line is not solid but dashed. If we look at the result, it's green dashed line. Or maybe what you are trying to display is not some continuous function, some discrete. So you would like just mark the values with the coordinates in x and y. And if you follow, so we end in this place. So if you would like to display only the points, discrete points, by by entering the string with small o, the points will be marked by small circles. So if I execute that and we look at so these are the circles. The next differs only that the marking is small cross. here, and there are many other possibilities. For example, small x will use crosses but tilted, and so on. Sometimes we need to put more information to the plot. For example, description of the axis. There are functions x-label for labeling the x-axis and y-label for labeling the y-axis. And if we execute that, we have here description for the x-axis. And note here, this is the description for the y-axis. And in the description, I use x to the second power, and it's written as a power here even. Sometimes we would like to have more than one plot, more than one function in single plot. This can be done using the command hold on. Hold on means keep the current plot and add to the plot another function and another plot. So here I add second plot to the previous one, and also called command grid, so that the grid is displayed here. When I want not to plot another function in the same plot, I issue the command off, and next plotting will be into empty window. Another possibility is that in the function plot we use more arguments. So here I will plot x against y in red color marked by crosses connected by dashed line, and x against sign of x in green marked by small circles and connected with dotted lines. The colon. If we execute that, then we have this this plot. We have still some time. Some functions, for example, max, compute maximum. It's nothing interesting. But if I have a matrix, capital A is a matrix, this one, and I compute max, I obtain row vector. What are these values? If you look at the value, the output, actually each value in the vector is maximum in the corresponding column. Why is that? The reason is simple. The first implementation of MATLAB was in Fortran. In Fortran, matrices are stored column-wise, not row-wise like in C, C# and most modern programming languages. So the max computes maximum on each column. And if I want to compute maximum of the whole matrix, I must call it twice. Abs compute absolute value. Size is a very important function. It returns the dimensions of the matrix. This is important when we will program some functions, and the function need to know the dimension of the argument matrix. That the function size will return the dimension. So 2 times 3 for the matrix T, 2 rows and 3 columns. If you would like to obtain just one dimension, you can call size for the matrix D, and for example the size of the second dimension. So I will another argument 2. I will obtain just the number of columns of the matrix. Length is function which was designed for vectors. So it should return length of the vector, independent whether vector is row vector or column vector. So it returns actually maximum of size of x. So if it is applied on vector, it's okay, but applied on the vector matrix D will return the biggest dimension. So it's 3 because it's bigger than 2 rows. After working with MATLAB, you will end with a long list of variables with your valuable results. And you would not like to repeat all the computations. You can save all the variables from the workspace into a file by issuing the command save and name of the file. .mat is the default extension for MATLAB binary files. So this will store all the variables. But if you would like to save only some variables, you can use this syntax: save name of the file and list of variables whose values you would like to store. And then the inverse command is load, which when you issue it, all the variables stored in the file will be populated here in the workspace, and their value will be restored. Accessing elements is easy. You can look at that and some formatting. I can say a few words at the beginning of the next lab, but we should finish by now. So thank you for your attention. Next week we will continue with data structures and programming in MATLAB, and next week I hope we will start to program some functions, and you will have chance to obtain the first points from the lab. Any questions for the end? It seems there are no questions. So thank you very much for your attention, and see you next week.